I'm going to talk about transistor, which is the smallest part of an SSD, which can store 1 bit or 2 bit or 3 bit, or it can be many more, but basically there are only three types of transistor. One is single level cell, one is multi-level cell, one is triple level cell. So the work of single level cell is just it can only store 1 bit information, and for multi-level cell it can store 2 bit information. For triple level cell we understand that it can store only 3 bit of information. So my first question was, how can a transistor store information or concept? It is just nothing but a concept, simple concept. So if you understand that concept, you will be easily understand how actually SSD store thousands of informations, uh, thousands MB of informations, right? So let's start. So first of all, you have to know what is bit, what is byte, what is kV, kilobyte, and what is MB, megabyte, something like that. So a bit is nothing but a single information which can be 0 or 1, which can store only 0 or 1. Okay, so like this. So now the question is, how many bit we need to make a byte? We need 8 bit. So we need 8 bit information to make a 1 byte, right? So we can say 1 byte equal to 8 bit of information. So if this transistor is single level cell, then we can say we need 8 transistor to make only 1 byte. So we can say we need 8,000 bit or transistor to make 1 kilobyte of information. So if a image is 4 kilobyte, then we need 32,000 transistor. You understand? 32,000 transistor we need to store that image. That much transistor we need. So this transistor is the smallest part of an SSD. Okay. Now let's understand how this transistor can store 1 bit of information. It is very simple. So the first thing is that to write, first we have to understand the structure. In this structure, as you can see, there is a control gate at the start here. So there is a control gate in here, and then we are seeing an insulator. It is called barrier or silicon dioxide. And there is, you can see a floating gate and another insulator. And in here you are seeing some silicon substrate, and there is a source and drain. So when we apply a voltage, which is called threshold voltage, so let's say this threshold voltage is 5 volt. When we apply 5 volt, then from source, a current started to move from source to drain. If current can flow from source to drain, we can say it is not written. It is not written. So we can say this value is 1. This value as a 1. We take it as a 1. We can take it as a 0 as well, but we take it as a 1. When current can flow from source to drain after applying a threshold voltage. I take it 5 volt as an example. If current is started to flow from source to drain, we can say this value is 1. That means in this transistor, 1 is stored. Now, if I apply for writing in the transistor, if I apply a high voltage, let's say I apply 25 volt, which is I taken it as a high voltage. So when I apply a high voltage, then this electron will start to flow from silicon substrate to the floating gate. Okay, so some electron, let's say 2-3 electron will move to the floating gate. And then if we apply again the threshold voltage, which is 5 volt, then what will happen? From source to drain, current will not flow. Then we can say this is written 0. Now, the question is why we need a silicon oxide or insulator? Because of I told you that already, this is a barrier. So to break this barrier and take those electrons to the floating gate, we need to apply a high voltage. So the important fact here is that even we disconnect the current source from this transistor, it will still store those electron come here. Okay, so we can say it will be in the same state. Why? Because of this electron will not able to move from this floating gate to down or up. I mean in the control gate or silicon substrate, because of this insulator. So these insulator are very important. Okay, so we can say when we put an SSD in the computer and take some images or some PDF file or something and stored in that and just plug it out, so information will never be removed. Why? Because of this floating gate will keep those electron which came into here. I mean, this will trap those electron. So it will never be able to flow from this floating gate to the control gate or silicon substrate. It will be stored in the same position, right? So like this way, if we add many transistor together, then we can say this is nothing but a full SSD. So by organizing many like as I told that 32,000 we need for storing an image at the beginning of the videos. So we can say by organizing many transistors together, we can build an SSD. So I just till now, I only talked about single level cell, right? Now I'm going to talk about multi-level cell. If I talk about multi-level cell, you will easily understand the triple level cell as well. So I will not discuss about triple level cell in this video. So I'm going to talk about multi-level cell now. So now, in multi-level cell, what happened? I talked about threshold voltage. So in multi-level cell, we need to store two information, like, I mean, 2 bit of information. So storing 2 bit, we need to like divide the threshold voltage in many phases. So what are the phases? There are 4 phases. So as you can see here, so these are the threshold voltage. We need to have 4 threshold voltage to store the information at like 2 bit of information. So first in here, as you can see, we have stored 1 1, then 1 0, then 0 1, and 0 0. So from this we can say we need 8 threshold voltage to store triple level cell information, right? Because of for 3 like bit, we can rearrange this in 8 ways. For that, we need 8 types of threshold voltage to understand what information being stored in the floating gate. I'm going to show you, like I'm going to visualize this so that you can understand better. Okay, so now you will understand that like how it's actually work. Let's start. So as you can see, this is a transistor. So I'm going to click on read button now. So if I click on read button, what happened? A threshold voltage had been applied, which is 2.5. So as you can see, this is the threshold voltage, which is 0 to 0. 0 to 3. voltage. So I applied 2.5. As you can see, the electron had started to flow from source to drain. So now we can say, as it is started to flow, current started to flow from source to drain, we can easily say that there had been 1 had been stored. That stored information is 1 1, right? 1 Okay, when I will click on write program, what will happen? A high voltage will be applied in the control gate, and then some electron will move from silicon substrate to the floating gate. And now if I click on read button, then the applying voltage will be 2.5 again. So we will check what value had been written. As you can see, 1 is not written because of electron is not flowing from source to drain. Now it is starting to apply 5 volt, which is this threshold voltage 3 to 6. As you can see, electron is flowing from source to drain, and that means the stored information is now 1 0. In this way, if I click on write program again, it will apply a high voltage in the control gate again, and some electron will again start to flow from silicon substrate to the floating gate again. Now if I click on read button again, so it will start from beginning again. 2.5 volt will be applied, and as you can see, electron will not able to flow from source to drain. Again, we will start to apply 5 volt again, which is the second threshold voltage. As you can see, electron is not able to move from source to drain. Again, we will apply 7.5 volt, and then now you can see the current is started to flow from source to drain. Now we can say the stored information is 0 1. So in this way, we can easily detect what information being stored in the transistor. So this is how a transistor actually work. So you can easily understand how triple level cell work, how like single level cell work. So single level cell is the most easiest one. We don't have to think about this. So when threshold voltage apply, if electron start to flow, then we can say it is written 1. If electron is not able to flow from source to drain, then we can say it is 0. So this is how actually a transistor work. Click on erase program. What happened? When electron started to flow from silicon substrate to the floating gate, then some electrons are stuck on the insulator. Or when we click on erase button, some electron also stored in the insulator, trapped in the insulator. It was not able to move from here to there. So in this way, what actually happened is it's wear out. Let's say after 100 times of writing information or thousands times of information writing, then this transistor will be dead. So this is how it goes dead, and this is called wear. So we have to distribute all the information in a way that all the transistor had been written almost similar times. Okay, so if this transistor, let's say there are 2 transistors, if this transistor had been written only 1 times, that transistor will be also be written only 1 times. And this transistor, let's say written in 500 times, so that transistor will be also written 500 times. So they will be dead together. Okay, in that way our storage, SSD storage will be not be less. Okay, it will not be decreased actually. Okay, now come to the point, like when we click on erase button, what happened? When we click on erase button, a high voltage will be applied on the silicon substrate, and all the electron from floating gate will come down to the silicon substrate. Let's see that as well. Like when we click on that button, then a high voltage will be applied in the silicon substrate, and electron will start to move from floating gate to silicon substrate again. So it will come to the that state again. Okay, so this is the things in this video. Thank you so much for being with us. And there are 2 to 3 more videos will come in our next tutorial. So we will discuss about full SSD system, how a full SSD work. So this is the SSD simulator. You can easily go to this website and check our simulator. Okay, so this is the full SSD simulator actually. So you can, in here you can understand how garbage collection work, how delete work, how read button work, and many more. Like I will talk about page, block, how they made on, and we will also trace the information. So all these things will be discussed in this like SSD simulator tutorial. Okay, thank you. Bye bye.